so let's get started. Be a little more informal since I don't have to worry about a giant audience. Okay, so this talk will be over upgrading Postgres, major versions, no downtime. A few tips and tricks along the way that some of them are in my book, some of them are not. And just go forward. So I'm on behalf of PG Edge, and we do some stuff. It's generally centralized around distributed Postgres, active multi-master clusters. We do other things too, but that's our bread and butter for now. And check us out when you got time. If you don't know who I am, which is probably a very good chance, I'm an author in the community. I wrote a book a couple years ago called the Postgres High Availability Cookbook, and it actually has a chapter on highly available Postgres upgrades for major versions. And there's a reason that says 12 on there. I've declined to update the book because, in my opinion, cloud's kind of taking over. And my next in-progress title that I'm going to be building a submission for my agent is going to be based on that. It will still have high availability in there, but it's going to have a cloud focus. So if you're interested in that, we'll see you in a few months. So we're going to be covering these topics, as I'd mentioned before. Some basic upgrade history, just so we kind of know where we've been, why the techniques I'm going to be explaining here are better or more advanced or whatever you want to call it. And you'll notice down toward the end, I've got some notes about Patroni. Patroni is a pretty aggressive high availability system, and if you try to do this process that I'm describing, it will probably break. So I've got some notes in there specifically for Patroni. It's a great high availability system, but it's too good for its own good, I guess you could say. All right, so let's start at the beginning. Who is familiar with this process? You upgrade a Postgres, you do PG dump after creating a new Postgres instance on the version you're trying to target. You dump the globals, so your roles and other stuff. You dump the database itself to get all the data out, and then you restore it into the instance, and then eventually you're done. That's pretty much how we used to do it all the time for everything. I think my first time I did it with Postgres was from a 8.0 instance to an 8.3, and then from there to a 8.4, and then to a 9.0. This was all before any of the more common systems were around. It looks kind of like this, like my crude drawing. Basically, that dump file in the middle can be a directory if you're using the more modern tooling. And essentially, it's just a transition system. Nowadays, at least, you can use parallel options to dump and restore using multiple CPUs. That wasn't always there. So these are all the things this is good at, right? Smaller databases, beginner-friendly, like you don't have to really know a lot about Postgres to pull this off. Like you use the tool, PG dump, PG restore, and that's pretty much it. And one of the really cool benefits of this is if you don't want to produce a binary dump, you can produce a SQL-only one, and you could just feed it through any utility you want, read the actual output. It's human readable. You're not really losing anything. It's a great way to extract your data in a way that you could, heck, even transfer it to SQL Server or Oracle or whatever you want to do. Nothing saying you have to stay with Postgres. Obviously, you have to transform the file a little bit if you do that, and you can set up your database ahead of time. So if you're upgrading from, say, 10 to 17, you can create your 17 cluster and all the replicas and have it ready for your restore to put it in. But with all of this, there's a few downsides. So the first of these, and probably the foremost that affects everyone if you're trying to do this, is the amount of downtime necessary. Because while you're doing the dump, you can't be writing to your data because that's data that's not going to be part of the dump. And during the restore, you also can't write to your data because that won't be part of the dump or the restore. So if you have a large database, it's just not going to work. Yeah. And also, this is fun, indexes are rebuilt the entire time. So if you've got a terabyte table, right, and it takes an hour to rebuild the indexes, even if you're loading in parallel, each of those loads is going to be a rebuild of that index, and you can't use the table. Well, I mean, you can, but it won't be very useful until those indexes are rebuilt. You might see a theme here. So waiting to dump the large tables, waiting to import the large tables, and waiting to rebuild the indexes of the large tables. I put that here 3 times for a reason, because that's the worst part of it. And then you have to do that for every database in your cluster. I know not a lot of people do this with Postgres, but you might have 2 or 3 or 4 databases that are different parts of your application, for example, and you have to do this whole procedure for every single individual database. Not fun. And then, remember how I mentioned there's parallel jobs? Well, that only applies to each individual thing the database is doing. So you can import multiple indexes at once or multiple data files at once, but it's only on a per table or per index basis. There's no way to split up the jobs so you're, say, having 5 workers to load one single table. So if you have like a 10 terabyte table, it's just going to be done when it's done, and there's really no way to speed it up. Yeah? So the PG restore process has a few phases. You can split it up if you want to. You could just load the schemas, then load in the data, and then apply the indexes last. That's the fastest way to do it, because then the indexes are built live instead of as the rows are coming in, so it's not doing page splitting as it's building the index. But that still can take hours if you have a particularly large table. So we all felt this pain prior to version 9.0, and version 9.0 brought us this procedure. Now we can just install both versions of the software, whatever version we're targeting. In the old, obviously we have the old version installed. Stop your database temporarily, run this handy PG upgrade command, and you're done. You just start your new database, regenerate your database table statistics, and your upgrade is finished. There's none of this exporting your data, no importing the data. Your downtime is in minutes now. Huge improvement. It looks something like this. So the whole procedure actually works with the 2 main ones that are in the middle are the primary instances. The replicas are transformed via rsync. That's not actually what happens, but it's a little more complicated than that. But essentially, you upgrade the main instance, and then the replicas get transformed via rsync, and then you do nothing else. There's no more exporting data. There's no waiting for hours for the whole procedure to complete, either importing or exporting, and that's pretty much it. And this is how I have personally upgraded every system since 9.0, going up to I think 12 at the company I was working at. And back before Postgres 9 was out, there actually was a version for Postgres 8.4 to get to 9 called PG Migrator. And actually I wrote a blog post on it way back in 2009 about it, I think. Very handy. So here's all the things you get with PG Upgrade. I kind of went over a few of these already. So there's almost no downtime. If you use the link option, it's the fastest you can possibly get because it's using under the hood elements with the file system to copy the references to the files rather than the files themselves. So you can do that, just by copying the file reference directory instances, and you get inode copies. Either way, it's very fast. It's great for huge databases. The largest database I ever did this with was, I believe, 56 terabytes, and it took less than 5 minutes. I shut it down, ran the thing, brought it back up, done. The problem, though, and there are a few of these with PG Upgrade, is, and this is a complication that I'll get into why this matters later, but you have to have all the software installed for both the version you're using and the one you're kind of upgrading it with. Some places have a process where they compile Postgres from source, or they're not using standard package systems, and that expects to be installed basically over, like it'll be var lib Postgres, and that'll be where it goes. It's not versioned, so you can't have both installed at the same time. So what they then have to do is they have to modify their build procedure to install it somewhere else, or they have to move the old binary somewhere else so they're not in the way. It's just a pain for people who have their own custom environments. And that's another reason this doesn't really work so well, is containers. If you use images or Docker or Kubernetes or something that's out in the wild now, upgrading via PG upgrade is very difficult because you have to have both your data directories mounted at the same time, the old data directory and the new data directory. And the old binaries have to be in the image, and the new binaries have to be in the image. So you either have to build your image ahead of time and also have it mount both the locations that you're planning to upgrade. It's just a pain. I've had a lot of discussions in Discord with people trying to do this, and we tell them, well, if you're using a container, you're probably better off just using a dump restore again. So there are other ways around it, but for beginners, that's usually what we just tell them, is to just use dump restore again. The other issue is rsync is involved. It's not part of Postgres. It's also really easy to screw up. Like, the directories have to be just, arranged just the particular locations. And if you even get one slash wrong, you'll corrupt your database and have to recopy it essentially when you bring up you have to rebuild the replica basically. And when I mentioned rebuilding the statistics, that takes a long time sometimes. The analyze in stages parameter helps a bit, but until you get the full statistics rebuilt, you might have really weird performance metrics for your queries until that's done. That actually might be going away with Postgres 18. Someone, I think, recently submitted a patch that will actually copy over the table statistics from the old data directory, which will be very handy. But until then, and that only helps with versions 18 and above. The other thing is, if you have an extension that doesn't exist for the new version, PG upgrade will obviously fail because it's like I'm trying to export the extension settings or whether other dependencies to this new version, and it won't work. So if you have an old deprecated extension that's installed in your database, what you usually have to do is go to your old database and then drop the extension, or remove a view that's using some deprecated element that doesn't exist in the new version anymore, and that complicates the procedure. So you have to do a lot of dry runs to make sure you don't trip over something like this when you try to do it in production. And by dry run, that basically means you have to copy your production instance to somewhere else, because there could be stuff that's not in your staging or your dev environments. You really have to make sure you're not hitting anything you don't expect. And I'm going to just say this again, PG upgrade is not meant for containers. It just doesn't work there. There are ways you can get around that, but I just don't recommend it unless you're an expert and you know what you're doing. It's just a bad idea. So, can we combine these two ideas and get something that's better out of the process? Yes, we can. So, here's the new procedure that I'm going to be describing in this particular situation. So, you create a new instance, right? You use whatever method you want to use. And then notice I changed PG dump to PG dump all. Basically, I'm just grabbing the schemas only and the roles and everything else, like global objects and the schema structure, nothing else. And then you create a publication as long as you're using Postgres 10 and above, right? Hopefully that's the case, because even 12 is end of life now. And then you subscribe to each one of those publications. And then you wait. That may be waiting for a while, but you just wait and it'll be done. And while you're waiting, your other database is still up online and doing whatever you want with it. It could take weeks. It could take months. Doesn't matter. The data will eventually get over to the new replica, or the new cluster, I should say. And then when you're ready, you flip the switch. Right? It's a little more involved, and that's the steps I'm going to get to in a minute. Yeah, sure. I'll get to that. Yeah, so the comment was, the longer you wait, the more chances you have something going wrong, like someone creates a new table or something gets out of sync, and the longer you wait, yes. The longer you wait, the more chances you have something breaking in the meantime. I don't recommend taking forever, but it's an option you have as long as you consider the possible repercussions. That looks something like this. Now, you recall my last diagram where I had like the PG dump artifact in the middle. We're basically just throwing that away and putting a synchronizing procedure in the middle now instead. So I grabbed a handful of parameters that I generally recommend. You don't have to use these exact settings. Basically, the only one that matters is you set the wall level to logical, okay? And you'll have to restart Postgres to get that to work if you haven't already used logical in your cluster already. I usually just set it to logical in every cluster I'm using because chances are I'm going to be using logical replication for something, right? Doesn't matter what it is. The other thing is these other options, basically I'm just bumping up all the max parallel workers and stuff because each of these subscriptions and each of the copy procedures and bootstrap procedures to copy all the data can have multiple workers. The more the merrier, right? Obviously, there's a limit to this. I'm not saying just bump it up to infinity, but just make it higher than it was because the default settings are probably not sufficient for an upgrade procedure. They're like 8 and 4, I think, are the initial defaults. So just bump them up to something higher. You don't have to really worry about it during the upgrade procedure. You can lower them after you're done. It's not that important. And then it starts this way. You just create a publication for all tables. Easy peasy, one statement. You can do it per schema, but it's just easier to do it for the whole thing. I mean, we're doing a migration, so hopefully we want all of our data, right? And then that name that I put there, upgrade 17 pub, is valid only for each database. So you can create that same publication in each database without causing any problems. So you don't have to have like upgrade 17 pub Postgres, upgrade 17 pub my app. It's just the same one. And then the cool thing about this is when it says for all tables, it means for all tables, okay? So if you create a new table from now on, like create table foo, that will be added to the list of tables in the publication. Now that can have a couple of effects because if you don't have that table schema on the target node, it'll go, hey, I'm copying data here for a table I don't have, and it'll stop replicating. But that's better than the alternative, right? Because you can create the table and it'll resume and you'll be fine. Otherwise, what would happen is you'd create the table and not know that it's not being replicated. And then you're just missing a whole bunch of data, and once you try to transfer to the new instance, it'll just be missing stuff, and you'll go, oh, we need to go back and try again. The other thing I usually recommend is this. So if you're using 14 and above, there's a role, essentially, that lets you delegate reading of all table structures to some other user. Now, normally what people, when they recommend this procedure, is they'll just say use a super user. Even if it's a dedicated super user, not Postgres, doesn't matter, just use a super user. I say, why? All you really need to do is be able to read the data from the publicating system, right? It's donating all of its data. You only need to be able to read it, and then it'll write properly on the target system because the replication user got special rights as far as writing to underlying objects. So before you do your dumps, you create this user, and then you'll be using this for the entire migration process. It's the least amount of roles necessary, the least amount of access and necessary to get the process done. That's usually the better way to proceed. The other thing you need to do is you need to modify the built-in Postgres firewall, right? So in this particular line, I'm just saying for the replication database, which is the special metadatabase for replication, and the migrator user we just created, I want to be able to read all tables. That's all I need to do. And from my new host that's going to be subscribing to the publication, and then whatever password processor you're using. In this case, it's scram SHA-256, which is the new default for password processing. And then this is the trick that's not in my book, is you use dump all to get all the roles. We all know that command, right? Anyone who's done an upgrade of any kind uses that. And then the other thing that I found was cool was the pgdumpall schema only option, not pgdump, pgdumpall. The reason I use pgdumpall here is because it gets all of your databases. So if you have Postgres, MyApp, foo, database, whatever, it'll get all of them. It also copies the create database statements and all the ownership stuff. So basically, you dump all the roles and all the schemas, and then when you replay that on your target instance, it will get everything pretty much exactly how it looks on your current system, assuming that they're compatible. Now remember, when you do something like this, you have to use the version of pgdump for the newest version of Postgres, because it will actually be able to communicate using the older versions, but not the other way around. You always want to use the newer dump, whatever you're targeting your database versions. Then we start creating things, right? So we all know initdb. In this case, you'll note that I added the data checksums option. And the reason I did that is because you really should be using data checksums. It essentially helps you avoid corruption, or if you do encounter some, it'll be caught a lot sooner. And it's a perfect opportunity, right? Because you're transferring all your data anyway, and so you can do whatever you want during your initdb. You can change locales, although I wouldn't recommend it. You can change your, whatever. But this is where you start. And if you're using containers, like the official Postgres image, for example, if you start the image with nothing like from scratch, it'll do all that for you. Like it'll initdb a new instance, it'll set it all up, and it'll be ready for you to work on it. So you don't have to worry about this if you're using containers. And I'm being a little cheeky here. So basically just copy the config files from the old cluster. Generally these days that's safe, because not really a lot has changed, and usually they're adding options, not changing old ones. So your old config will, like 9 times out of 10, will work on the new system. But if you're really concerned, what I would recommend is going through and curating the configuration file, like see which options you changed in the old one, see if they're still valid in the new one, maybe see what new options are available in the new one, and maybe tweak a few of those too. But if you're just looking to get all this done and over with, then you could probably get away with this, right? And then you start the database. Now you're ready to start your upgrade. And again, you can do this for anything. You could create your instance, you can create an army of replicas, you can even create downstream logical replicas from your new cluster before you copy a single byte of data from your old database. It's very, very convenient for getting stuff ready before you actually transfer data. So this is where the fun starts. You import your roles first, and then that schema file I created, the pgdumpall, you just import that next. Roles are requisite for the actual table structures and views and procedures and everything else. And then you subscribe. So you'll notice that I added with disable on error true. What that basically does is anytime the subscriber system encounters any kind of replication error, it could be a duplicate key, it could be table missing, it could be whatever, it will stop the process. And this is very important because I actually, when I monitor the Discord for the Postgres, the People Postgres Data Discord is very popular for newbies. And one guy had actually tried this procedure, very similar, and he was transferring out of from his local cluster into Amazon. Okay, very common process. The problem is that he didn't include disable on error true, and what he did not realize is one of his tables had a missing column because he exported his schemas a while ago and hadn't updated it. So what was happening is all the tables were being copied, and that's part of one single transaction. So what happens if that one single transaction fails right at the end during the initial copy procedure? Well, what happens is Postgres goes, oh, I'm going to abort this whole transaction. And then the subscription goes, oh, I failed, I'll try again. So it reconnects and tries to establish that subscription all over again. So he was like, why did my bill for doing for my Amazon instance, why was it a terabyte of transfer last night? I didn't do that. And then we dug into it a little bit more, and we're like, yeah, you did, just unintentionally. We looked at his logs, we're like, oh, there it is right there. Yeah. I'll get to that. So, yep. I have a slide later for other techniques. Now remember, this is the easy way. If you have a not very complicated schema or a not very complicated database, this is a perfectly reasonable procedure to use. But again, even if you don't use one subscription for all the tables, you're still going to want that disable on error, because there could be some underlying flaw you missed, and then you don't want to have it keep trying over and over again to copy that the schema and all the data, because it's going to fail. And then you'll have to monitor your logs and then fix it on the fly, whereas if you kind of watch on error, then you'll still see the error in the logs, but it won't keep trying on you. You'll see the error, you'll be like, oh, well, I need to fix this, and then re-enable the subscription, and then it'll retry. So you get a little more control over the procedure. So are we done? Almost. So we have to do a few more steps here. Primarily, we have to make sure we're actually done. Like, did the data copy? Is it like everything what we expect? And then you'll notice I bolded copy sequences, because that is not something that Postgres logical replication does. Sequences, for whatever reason, are considered data, but they're not part of the logical replication system, so you don't get them. You can create them. They'll be in your schema dump, and they'll be on the other system, but they'll all be set at 1. And if you don't know this and you try switching over after your data is copied, you're going to start getting primary key violations if you're using serials or and I've seen this happen before too. They're like, oh, well, I'm suddenly getting a bunch of duplicate key violations and my data's not working, and what do I do now? Well, now you have to go and export all of your sequences now, because you're already switched and it's probably too late to go back. So the first thing you want to do, yeah? No, you don't need to do any of that. The subscription handles all that for you. You don't need to create replication slots beforehand. You don't need to bootstrap them to some existing value. When you create the subscription, what happens during the initial bootstrap is it goes, oh, new subscription. I'll copy all the data for now, but it also creates a slot for you on your behalf. And after the initial data is copied, it will start replaying from that position on. So you'll get all the existing data before that transaction started as part of the initial sync, and then afterwards you get all the new transactions because it's part of the slot already. At least that's the process I usually recommend, because if you don't do it that way, then yes, you have to create the slot first, copy the data initially, set up the position on the remote upstream system using the origin tables. It's a lot of surgery that's just not necessary for something like this. But anyway, in the logs, what you actually get here is you'll notice that I've highlighted a couple of elements in purple. So remember, I set it to disable on error. So I got a kind of a capture of this because I also inadvertently screwed up, but it was beneficial for the slides, right? So I created a table because, remember, for all tables, so I created a table foo, and then I looked at my subscriber. It obviously didn't have foo because I didn't export the schema. And then it said, oh, I don't have this table, so I'm just not going to work anymore. And that disabled my subscription. So if you want to watch for something like that for like right here, you'll disable on error, you'll get an error, and then the subscription will stop. And then you just fix the error and then re-enable it, as long as it's fixed. If it is broken some other way, it'll stop again, but at least it won't keep retrying without having you know about it. And then you end up racking up a terabyte of data transfer charges in Amazon. Another cool thing is Postgres has been continuously adding new catalog views for us. The stat progress copy table is very, very handy because it will tell us basically how much its estimate of the table copy is completed. So if you go to your new instance and you see a bunch of these copies in progress, then you're not done syncing, right? And if you don't see any copies, okay, well, then you check the logs. Are there no errors in the logs? You're probably done. We have other ways of checking, though. The other table is pgstat subscription. On the target system, it will say, oh, I've got a subscription to some upstream system, and I'm connected and working. Now, if this isn't if the PID and the worker are both blank, and actually a lot of that rest of the results will also be blank, that means it's not replicating. And even if the initial if the initial copy is done, this will also be filled out because it's syncing all the live data. You want this to be active. If it's not active, something went wrong. You need to go back and check your log and see why it's not. Another thing you can check is the pgstat subscription stats view, which will kind of give you a summary of the subscription as it's been working. In this case, you want the apply error count and the sync error count to be as close to 0 as you can, or just not increasing, because it's a cumulative fields. It will keep growing. So if I left my errors in here from when I broke my subscription earlier, it would be like 2 and 2 or something. I corrected it and then recreated the subscription. I didn't re-enable it. I actually dropped the subscription and recreated it so I could zero out the values. Don't do that, by the way. Just re-enable it. Either way, as long as those numbers aren't increasing, you're probably good for now. Yeah, there's like a pgstat reset function you can also call that'll do it, and that's why that field is blank on mine, because if it's blank, it means it's a new subscription. It just never got reset. The other one is our favorite query for checking for synchronization lag. Right now, you want to run this on the old system because that's the one that your subscriber is connecting to. That's where the replication slot actually lives. And then I'm just, the database name, the slot name, which is the same as your subscription name, right? And then the actual amount of lag. You want that to be close to 0 as possible. So basically, when you're ready to do your transfer and you shut off traffic to your old system, you want that to basically drain down to 0, because that means all the data has been copied over to the new instance. Yeah? I'm getting to that. Yes, as reasonably observed, if you shut down traffic to your old system, it's not 0 downtime. I'm getting to that. It's a reveal, right? And then that step I'd mentioned earlier, we need to extract our sequence values. This is a simple trick. There's actually 2 different ways you can get this from built-in Postgres catalog views. I'm just kind of cheating, and I'm creating a SQL file, right, of all the different sequence values, and then, unfortunately, you have to do this per database. You could probably script this, right? Not a big deal. But you'll notice I'm also adding a buffer of 1,000 values, basically so I know that that's when my jump occurred. You can pick larger buffers or smaller ones. It's up to you based on how much data you're transferring on a regular basis, how many new rows, how many new IDs you're generating. But this will work. I've done this a couple of times when doing data migrations for other customers. And then you do this. You just load all of your sequence values per database. And This part, again, I just recommend automating. Just run the copy statement in some SQL file, produce the SQL output that sets all your sequences, and then import it as a single step. Because what you're probably going to be doing is you'll want to do this as close to your transition time as possible to reduce your amount of downtime. And then you switch write targets, right? Because once you're done, you want to point all your traffic to the new system. And I say that like it's just, switch write targets, you're done. No, because people have very complicated stacks. Sometimes it's DNS-based, sometimes it's, you actually have to deploy the application again because they've hard-coded the IP addresses in the app for some reason. I've seen it. Don't laugh. People do it all the time. Whatever it takes, there's going to be more involved than just saying, okay, redirect all your traffic to the new instance. The other thing you need to remember that a lot of people forget are automated jobs, like cron jobs, anything that's in a Kubernetes scheduler. There's lots of stuff that you may not realize you have as part of your inventory. So what you might also want to do before all of this is make a list of all your automated things and be like, okay, well, what do I have to do to these to make them point to a new direction if that's necessary? I do have an answer for this too. Before you get ahead of me, you can save yourself a lot of time. And then finally, when you're done, you just drop the subscription. Or if you're kind of nervous about saying drop, X because you can't get it back, you just disable it, right? Just alter the subscription, disable it, and then if you're really worried, you can enable it later. Like maybe, I need to run this thing on the old database for some reason, and it'll transfer the data over. And then you can re-enable it and then disable it again. So you have that option. So now I'm going to get to all the advanced stuff that my heckler up here has been referring to, essentially. All right, technique 1. I'm going to be getting to a near and dear utility that we all are probably familiar with, PG Bouncer, right? If you don't know about PG Bouncer, go to that URL. It's one of the oldest, probably, proxies for Postgres that exists. And they recently added support for, maybe not recently anymore, but as of version 1.21, they added support for prepared statements. So it's a good option to have if you want to make sure your transfer works properly. So this basically solves the issue of your transfer targets in my last slide, right? Because if all of your systems are connecting to PG Bouncer instead of directly to Postgres, you can redirect where PG Bouncer points arbitrarily and it doesn't matter. And the reason you can do this is because of the pause resume feature, which basically says, pause says, okay, all transactions that are in progress, I'll let you finish up, but no more new transactions. And then resume says, okay, you can go now. And why that's important is I'll get to in a minute. Now your stack looks like this. All of your traffic from PG Bouncer is going to your old cluster. You've got your logical copy in the middle there. And then once you're done, like you pause your application, do all of your fancy stuff like transfer all your sequences, maybe check on your logs to make sure that everything's really, really done, and then you resume. And if you automate all of this, right, it can be a matter of seconds. And at that point, how long were you really down? Like, does the application notice it? Do your end users notice it? That's the important part. And here's how it works. Very simple. PG Bouncer has a lot of settings. None of them matter, right? There's a section called databases, which lets you define like a database alias for however many things you want PG Bouncer to masquerade for. But if you do star equals, that's all databases. So any database that gets routed through PG Bouncer will go to your old host initially, right? And then you connect PG Bouncer and say pause, right? You're saying, okay, time to drain all the transactions that were in progress. And as soon as that PG Bouncer is determined all the transaction data is drained, you can actually look at PG Bouncer has other views where you can actually say like show pools, show transactions, show whatever, and you can actually see the process, like are they actually still active, how many remain to be drained, so on and so forth. Or you can just be mean and cut all the connections and just say I'm done waiting. Up to you. But now is when you actually start looking at your logs and being, okay, well, are my syncs actually done? Do I want to re-export my sequences and update them one final time? Whatever. It's up to you, depending on how paranoid you are. And then you just change the target. Now the star is pointing to new host. And then you cause PG Bouncer to reload the config file, and you're done. Suddenly all your traffic will be going to the new target. That's the whole upgrade process. Now I don't have to worry about how many scheduled jobs there are. I don't have to go to each, I don't have to redeploy my app. It just goes to the new target as long as PG Bouncer is in the middle, right? And this is the resume portion. This is what tells PG Bouncer to reload. You're saying system CTL, or if you're not using system CTL, I think you can use a hup. You can use a kill hup, and then it'll tell PG Bouncer to reload. And then you can send the resume command, which basically says, now that you've rewrote the configuration file, use the new database target that I've configured. And that's pretty much it. There are some caveats here, though. So the main issue is that PG Bouncer is not an easy piece of software to use, right? If you're using SSL certificates especially, you've got to set it, without having it be a man in the middle, you've got to configure your certificates properly. If you're having it handle auth, because it has to handle auth because it pre-auths the connection and then passes that on to Postgres, you have to create a function, and you've got to create a special user for PG Bouncer to use, and it's just a whole thing. There's tons of blogs that explain how to do this, but it's not for the faint of heart. You definitely need an expert or someone at least that can kind of guide you through the process, or experiment yourself a lot to get it to work. Not easy to do, but you have time, right? You're going to get your cluster ready for the upgrade before you do all this, and this is part of the process of getting ready for the upgrade. But you can also take advantage of it from now on. Now that you've upgraded, you've now got that proxy ready for your next upgrade because it's just there now. The other technique, which our man in the back kind of alluded to, is maybe we don't want to use one giant transaction, right? If I've got terabytes of data to transfer, like, I don't know, my 56 terabyte database I upgraded a while ago with PG Upgrade, maybe I don't want one giant transaction. Maybe that's not the best idea. Or maybe I have thousands of tables, which is a larger catalog, which is more complicated to set up. Maybe I don't want 10,000 tables in one single subscription. Maybe that's not a great idea. Or maybe I'm transferring to a country that doesn't have the best network connection, right? And if that network connection gets disrupted, that also disrupts your subscription process, because the initial transaction subscription copy phase has to be one single transaction. There's no other way to do it, because that will screw up where the slot is, because it creates a replication slot based on when it starts the initial copy. So if it loses that initial connection, the replication slot has to be dropped because it's no longer valid for the data that's exporting, right? Because you need a consistent snapshot for the data you're sending across for the new data to be consistent with that snapshot. So what do? You say for no tables. This is a subscription that has no publication that has no tables in it at all. It's just empty. It does nothing. But you can still subscribe to it, okay? Because what you're basically doing in this case is you're establishing the relationship between the two machines, essentially. You're creating that initial replication slot. You're not transferring any data at all. And then what you do is the same as before, right? It's the same subscription. You're still disabling on errors, but now there's not going to be any errors unless you got the connection string wrong or something. And then you do this. You can say, oh, I just want to add one table, or I just want to add two tables, or I just want to add a schema. And it's up to you how big or small your batches of things you're adding to your subscription are, because, to your publication, I mean, because everything else will be ignored. So if you have 10,000 tables, you can start with 10. You can then add, I have this huge table. I want to make sure that goes first, because if I do it last, then I'll have some trouble. Set it up any way you want. Remember, you have, in theory, right, you have days, weeks, whatever. I don't recommend extending it out to that point. But if worse comes to worse, you can make it work. Or you can throw it away and start again if you run into a real big problem, but you have that freedom. And now the fun part. So I mentioned Patroni earlier because it's a great system for monitoring your high availability. It'll keep your database up pretty much come hell or high water. It's actually hard to break your database when Patroni's watching it, although I will admit Patroni is a pain in the butt to set up, right? Because you've got to get etcd and HA proxy and all the different other parts properly configured, which is not trivial. I mean, I think it took 2 chapters in my book to do that because you've got to set up all the prerequisite stuff and then actually get Patroni running. But the point is, it is great for keeping your database cluster online. Unfortunately, it's also pretty aggressive about it, right? It's going to, if there's a problem, it'll shut down your primary, promote one of the standbys, and suddenly, remember the publications are logical slots? What happens to logical slots when you have a failover? Anybody? Yeah, they're gone. There's other problems, but without the logical slots to handle the logical application, your subscription is suddenly dead, and you have to reestablish it from scratch. So if you run into some kind of issue that causes you to have a failover, suddenly your logical application is dead, and then you're not copying anything, and you have to start over again. So I've got some settings here that you can help out with. Now, I mentioned that configuring Patroni is a kind of a black box, and it is. The initial bootstrap part is annoying because you've got to set up a YAML file and set up the initial DCS for the configuration store and a bunch of other settings. But if you want to save yourself a ton of trouble, Patroni has a cool command called patroni-ctl where it just says, if you configured it properly, which honestly you probably haven't, I have to work on it myself sometimes. But either way, you can use patroni-ctl. If you need to give it the path to your full configuration file, do that because it might not work if you don't. Either way, it will connect to the cluster and say, here's your current configuration, if you use show config. And edit config will let you edit the configuration. The reason this is important is because we want to change some things. Remember those initial settings, right, where I was setting the wall level to logical and I was setting the replication slots and a bunch of other stuff? Well, that's where that goes, because that sends it to all the members of the cluster, the primary, the replicas, whatever. So they're all consistent. And the use slots is important because we want Patroni to maintain the replication slots, not just between the different replicas that it's maintaining for the high availability purposes, but also because we're using the logical slots, and we're going to need this option for this. Right? So what we're doing now is we're saying, okay, Patroni, we understand, we want full control over the cluster, I get it, but please, for the love of God, maintain these slots for me. I need them. So what will happen is Patroni will actually connect to each database replica and say, okay, these slots, I'm just going to make sure they're up to date. So it'll, every few seconds or whatever its heartbeat period is, it will transfer the replication slot locations from the primary node to all the replicas for logical slots. So that, at least if you're using it this way, because I'm using the logical type and output for the PG output plugin, that's how it's doing the subscriptions. Now, if there's a failover, the slot will still be there. It will still be compatible. And here's the cool thing. Even if it's behind a little bit, say it wasn't updated very recently, what will happen is the subscription actually keeps track of what its last LSN copied is. So it'll go, oh, you're behind where you should be. Let me fast forward to the location where you should be at. So it's better to be behind than ahead, obviously, when slots are being concerned. that's very handy. Now, I will mention Postgres, I believe 17 made it possible to do this internally. Like there's a system that copies over replication slots that's built into the configuration. But again, Patroni is not designed for this, so you'd have to turn off the replication slot management or tell it to ignore them. Otherwise, what it will actually do is it'll reach in and rip the slots out that you're maintaining with the Postgres configs. So 6 of one, half dozen of the other. The reason I didn't mention that here is because that only affects version 17 and above. And it's currently not possible to upgrade from 17 to anything else. So maybe when I revise this presentation, I'll say, okay, now here's some new settings you'd have to use if you're upgrading from 17 to 18 or 19 or whatever. But for now, this is the important thing you need to do. So are there any other options? As I'm here from an active multi-master company that we have our own extension that handles this kind of thing, kind of, right? So what active gets you is, in this case, our Spock extension. You can install it on any standard Postgres. Currently, it takes a couple of patches because there's a couple of hooks in the Postgres core that aren't really there. We had to add. So you'd have to compile it from source, or we have a tool that will download the tarball for you to install. But either way, what you get essentially is, remember that problem we had earlier where if you create table foo, it's not on any of the logical replicas because you didn't extract that schema and replay it on the system since you did the schema extract. Well, now it does because you can configure extensions like Spock to capture DDL statements, and they'll replay it on all the logical replicas automatically. Our particular solution also includes like create role. So if you create a user on one node, it's just on all the other nodes, and that's required for user ownership or for table ownership and view ownership and functional, ACLs and other stuff. So that's important. And then the upgrade process is, I wouldn't say trivial, but it's so much different. So now all you have to do is say, okay, I want to upgrade from 16 to 17. Okay, my cluster is currently 3 16 nodes. I add a 17 node, and then I let it sync. Then I drop one of the 16 nodes. And then I do the same thing again. And I can do that as many times as I need to replace every node in the cluster, and suddenly I'm on 17, and I never went down for a second. And the thing is, with active nodes, the other benefit you get to that is if you redirect traffic to one of your other nodes, it's accepting writes. All the nodes in the cluster are accepting writes. So if you want to be extra super safe, you just change your traffic pattern so none of the transactions go to the node you're decommissioning. Wait till the 17 is up to date, add it to the pool of nodes that you can interact with, drop the old one. It's a rolling upgrade process that you can only really do with active systems. Before I worked for PG Edge, I did a similar experiment where I was working with EDB and their Postgres distributed product, and it worked the same way. Like you add a node, shut it down, bring up a new one, and your whole cluster is up the entire time. You never have to shut down anything. You don't have to set up this logical replication stuff. It's all, as long as the node is part of the cluster, you're done. So if there are any questions that weren't asked during my little song and dance up here, you can ask them now. You can ask them after the presentation's over. You can throw tomatoes. I don't really care. But if you don't have questions here, you want to talk about the Postgres Edge product, Spock, you can come to our booth. Up to you. Anybody? Yeah?
So one thing not very clear, when you talk about to upgrade from PG16 to PG17, you were saying you put up a new secondary and make some change on publication to subscription. And I'm wondering, where is the initial data coming from? Because after you, I presume something like a one out, right, or take out. Do we get to a backup from the primary and restore it to get the initial state for the
Okay, so I think I'm interpreting this correctly. So what you're asking is, I keep mentioning the initial sync, but I'm not telling you what's involved.
Yeah.
So what's actually happening under the hood with a Postgres logical subscription, when you say create publication, there are some options you can set. And some of them involve doing an initial data copy. And you can also set those on the subscriber for do I do an initial data copy or not. In this particular situation I'm describing, the answer is always yes. So what's happening is when you create subscription, blah, to some publication upstream, you're making the implicit assumption that those tables you're putting data into are empty. So what's going to happen is Postgres goes, oh, you want an initial data copy. Okay, it actually will, under the hood, it will send a copy statement through the wire and send the entire table that you're copying over to the recipient system. So if I have a 1 terabyte table, it'll send the whole terabyte over. As soon as I create the subscription, that's what happens. But what it does when you create a subscription, the other thing it does is it creates a replication slot on the publication system. So what you end up having are two things then. The initial data copy, which essentially start where that subscription, where the subscription and the replication slot start. And then you have the position of the slot is consistent up to the time where you started the initial snapshot. That initial snapshot is where all those copy statements also begin. So they transfer all the data to the new system, and then when they're done, Postgres will naturally transition to a streaming replication setup where any new updates or deletes or inserts or whatever will be copied per transaction over to the new system. Yeah, it'll handle it all for you. The only thing you need to do is the initial, you need to create the tables. Like you have to, that's why in my step over, in the beginning I say create a file of all your schemas, like create tables, create indexes, whatever, import that in the new system, so at least you have a shell to receive the data that's going to be coming over. Okay, so the question seems to be, can you shut down, or can you basically convert a physical replica into a logical replica? The answer is yes, but the scenario involved in that is so much more complicated. I'm not even going to get into all the steps necessary here, because what you really have to do is, when I was working at Second Quadrant, we actually had a document for this. Right? So what you basically have to do is you copy the data over, okay? And then, you have your physical replica. What you basically do then is you cut the subscription and you find out where there's tables in physical replicas and logical replicas where it tells you where, and there's a table on the subscription side that tells it where to look. It says, what LSN should I grab? What you need to do is on the upstream system, the primary, you find out what the LSN was that it was up to date as. You create a slot and you set it to that position before you do anything. Then on the subscriber, you shut it down and promote it, right? So now that it's a physical system, and now it's a logical subscriber, technically, it could be anyway. Then you create the subscription, but before you connect it, there's a table called subscription origin or something like that, publication origin. You actually have to insert into the system catalog the LSN on the upstream system that it needs to basically sync at. Because if you don't do that, what will happen is Postgres will go, oh, this is a new subscription. I need to fast forward that slot to the new position because I don't have a position for it. And then you'll lose all that work that you snapshotted, and it's really easy to do wrong. I didn't describe it here because nobody but an expert should ever do that.
There is also a problem if there are some transactions in flight when you create a snapshot and...
Right, but that's what I mean. You have to create the snapshot. in the LSN, when you stop
Really easy to
conversation,
break something.
recreate the slot at that LSN so it can't go forward. You have to do it like as an atomic action. So you have to basically, the easiest way to do it would be to create a transaction, export the snapshot, and then it's a stable snapshot.
People still do all these things because, as far as I understand, when you like,
I'm really sorry to interrupt, but can you take the discussion?
Yeah, sorry about that.
Sorry. Thank you so much.
Will you be using the handheld for your presentation? The clip-on?
yes,
That we... Check 1 2 1 2 1 2. Check 1 2 1 2 1 2 1 2 1 2 1 2.